Hello, everybody! We're here, and we're here to talk space. I'm excited. We're going to be talking about Panspermia versus Abiogenesis and kind of talk about where we're at, what we think about it, who thinks what. And I brought people here that are smarter than I am because what do I know about anything ever? So today we've got Dapper with us, we've got Nikki with us, we've got Paul with us, we've got Feline with us, we've got Did I say Dapper already? We've got Dapper with us. We got Landon. I'm super duper excited. This is going to be a lot of fun. Sadly, Reds was had to cancel on us, unfortunately. I did set up for a puck cam, and I moved his bed out here and everything, but instead of, he's decided he wants to lay on the couch instead. So he's over there. But I'll be doing a little bit of sketching and messing around in the meantime while we get this rolling. And if you are a member or a Patreon, you will be able to join us in the Discord to join the call. If you are so interested, I'll be keeping an eye out for questions, but make sure that you tag me, otherwise I'm not gonna know. And welcome back to our wholesome weekend. We've been doing such a good job being wholesome, and I love it. Everybody, hello! How are you?
Hello. I'm, my brain's a little mushy because we had one big brain conversation, so I don't know how good I'm going to do on this one, but whatever.
How many big bag conversations can Dapper have in one day?
Yeah.
I think 2 might be the limit.
And good morning, good afternoon, or good evening, depending on your time zone and latitude. You're really secular astronomer.
I'm so excited. I think this is the third time Landon's been on this channel. Because I think last time we were here talking about math. We had 2 episodes talking about math and whether or not colors were real.
Yeah.
It's philosophy versus mathematics. Oh my god, Puck decided to lay on the bed. Facing away from the camera, but you know what? I'll take it. Thanks, bud. Thanks for being a good sport. Alright, so I think we should probably just do a brief breakdown of what abiogenesis and panspermia actually are. If the thumbnail didn't give it away, abiogenesis is life coming to fruition on Earth, and panspermia is life started on another planet and then landed on Earth. This is a very, very rough explanation using cartoons. But what do you guys think? Do you guys think one is more likely than the other, or...
I think first of all, your definitions are pretty good at the 10-kilometer level of things. There certainly are details of there, but I also want to say just as a prerequisite, I'm a physicist, astronomer, and planetary scientist. I am not a biologist. So, but it's interesting that astronomy and biology have been merging this emerging science called astrobiology. So I'll try to do my best in maybe talking about from the point of view of astronomy, physics, planetary science.
It's certainly one of those.
Talk about the two items.
It's certainly one of those things that is not only is this biology, but it's also chemistry and physics and astronomy and like mathematics and planetary study. And it's like a converging point of a ton of different science.
And there really isn't an answer because science is about questions, right? I think that if you really want to say abiogenesis and panspermia are really questions people are asking about the origin of life, and so it's really it's not really like it's the difference between creationism and Darwinism. It's not that. It's different questions being asked, and people ask different paths and processes. So the versus stuff, I would say discussing, it'd be better to discuss abiogenesis and panspermia, the questions that are being raised and what has been proposed about both. That would be relevant as opposed to it must be one or the other, because they also be neither too.
Yeah, I'm kind of thinking, I'm sort of along the lines of a little bit of column A, a little bit of column B, that the Earth was so ripe with the materials, the temperature, what was needed, and then that nice little boost from a comet going by with just the right mix that it just it needed a little bit of both.
Yeah, and by the way, Smitty also points out that psychology and sociology also are involved in sort of the whole question about life. But one of the things you probably need to start off from the beginning is to ask questions about what is life, right? If you're going to talk about something moving from someplace to someplace or starting someplace, what is it you're talking about? And it turns out, at least from what I see, there isn't really a solid definition of what is life.
Yeah, I think that's fair.
And
that certainly depends on what field you're talking about. And when you have a convergent point, all the fields have to agree on what they're going to say.
Yeah. In planetary sciences, one of the big things, we study planets, and particularly planets are often where interesting chemistry and other things happen, right? As opposed to on stars that are too hot to really do anything other than being balls of plasma with occasional stuff around it. So planets are where things happen more often. About what is it that we're talking about happening? And I use a definition that sort of a definition that that life has kind of three specific properties I look for. I look for replication. I look for sort of self-repair, and I look for metabolism on the environment. So having sodium and chloride ions come together to form salt is not life. You need to be replicating. You need to be in an environment where there's damage and repair from that damage, and you also need to have some way of taking things in and things out, as metabolizing in your environment are kind of my setup of what would constitute life. Now I realize that a biologist would have a much better precise thing, but some of the definitions I saw are actually paragraphs or mounds of papers,
like a whole
like
discussion paper about like what are you considering life? Here's 300 pages.
Well, there's a definition that I like, which is
Please.
a chemical system that's able to maintain thermodynamic disequilibrium with the environment and which is capable of evolution.
Yeah, I think that one of the things I typically throw in as well is imperfect replication.
Yeah, you'd have to be that for you to be capable of evolution, because if you weren't an imperfect replicator, you couldn't evolve.
Yes, and that's part of the self-repair is maybe it's imperfect self-repair as well as imperfect replication. Maybe that's the thing to think about, because typically you want to have some sort of effectively chaotic events that are sending the system off into states that can find new niches.
Right.
Now,
so complicated.
Any other definitions of life that are out there that I like your?
I mean, like, there's the one that you get taught in like grade 9 science, but I just assume that's wrong.
What is it?
You've got to be able to reproduce. Oh God, grade 9 science. Do I remember? You've got to be able to reproduce. You breathe.
Yes.
You have.
Well, there's replication.
You have to consume. So like you're like that would be metabolism. I feel like there was 4. I feel like there was one more. I mean, would you make dying a requirement to be living? You have to be able to die.
Generally, when you have a state of life, you also are defining a state of not life, right?
Right.
Well, I think there's a difference between not life and dying, though, right?
But I would like to point out the immortal jellyfish. The immortal jellyfish technically doesn't have to die, because it's one of the few jellyfish that can return to a polyp state and then produce more hydras after already being a hydra. So it can do that indefinitely. So I would say that, by defining life, you've also defined something that isn't alive, which means you could transition from alive to not. But I don't think you have to be alive.
But by the way, not life and death, I think, are different.
Yes,
death is something that was life that has lost the fundamentals of the definition of being living, I think. But again, death is another thing you have to kind of define. But for panspermia abiogenesis, you need to kind of talk about, well, what is it referring to, right? The presence of a molecular of an organic molecule is not life, as an example, right? That's the
right.
thing that there is, there is inorganic and organic chemistry, but that itself doesn't mean there's something living there, and that makes it that's a challenge in detection. Trying to detect life elsewhere is well, what is it you're detecting?
Well,
now,
I got a question that I just want to note before we get too far, and it's for Landon. What would be a satisfactory answer on abiogenesis? Would it be that we have a direct pathway from pure chemicals to a cell that replicates, and is this done in a single go? Question marks.
I again, you're so I'm addressing biology from a physicist standpoint,
right?
And we jokingly sort of see biology as essentially as very complex physics, but in fact that's not a good process to try to do it. But from a physicist standpoint, given physics, you can create living things, right? An example is, well, the universe has established it here on Earth. How it's done is typically, you having a suitable environment where that replication, self-repair, metabolism can exist, that the imperfectness system can allow things to evolve, and it stays stable enough that evolving can do interesting things. When we talk about intelligent life from a planetary sciences point of view, we use a more practical term, which is life that is capable of announcing its presence through detectable means. And we detect means certainly by electromagnetic radiation, radio waves, light, sort of thing. So if intelligent life can announce its presence or demonstrate its presence, and we can detect it, then we've detected intelligent life. Now, is it possible to have life which could be intelligent, but we're not intelligent enough or capable of detecting it? That's also quite possible. There's a difference between what you can do and what is, right? So our ability to detect intelligent life depends upon it being able to announce its presence through some detectable means. And electromagnetic radiation is one of the ways. I don't know that maybe life can generate gravitational ways and let us detect it. But those two are sort of the best remote detection of things, and almost
exclusively. Yeah, because we also have to do it from a distance, right? We can't necessarily recognize it. We can't go there.
Yeah.
Right? And so because we can't go there, we have no other option for what we're capable of doing or finding at the moment.
Yeah, and so my comments about biology are not because I dislike it. In fact, I'm quite in awe of its capabilities, and particularly people in genetics. I mean, I was at exchange I had was with Dawkins, where I was explaining how amazing it is that they were able to take and sequence DNA and then talk about the tree of life and when it might have branched here, and basically going backwards in the DNA to sort of determine how it evolved and when and so forth. I find that quite amazing. And his comment back was, well, I find it amazing that you can take a handful of photons and tell me the star's temperature, mass, size, and age and so forth, right?
There's one thing that I absolutely love. Well, a handful of things that I absolutely love about people who do science and within the scientific fields, and it's the way different when two different fields of science and like top tier people in those fields of science get together, and they can appreciate and recognize how they're different but also the same, and converse in that way, but also when they throw shade at each other. Both of those things are hilarious and amazing, and I love every second of it.
Yeah. So it was, respectively goes in awe of each other as a field and what we're able to accomplish. But that's where we were talking about, the detecting intelligent life, right? Detecting life, right? And being able to maybe look at some really complex organic molecules within a atmosphere of a planet, and suggesting that there might be life there, is detecting life, but it may not be intelligent, right? So probes that we send out in space that have come by Earth, we've asked it to look at Earth and tell us what it is. That's an example of remote sensing, and we can see, Earth's atmosphere is all full of all kinds of interesting chemical stuff.
Well, I think that's what I was a little bit getting at when I was saying a little bit of column A and a little bit of column B. Earth had the necessary, it was stable enough, it had enough of the right things, whereas a comet, let's say you had like something that was frozen and able to reactive and freeze and then go back and forth, right? So you get something like a tardigrade. Obviously not as complex or as like a current tardigrade, but you get something like a tardigrade, and it can survive in these harsh conditions. So it would go by, and when it would get warm enough, it would develop. But when it went through, it would have to stop. But if a comet went past Earth and Earth had the right material, something that was having trouble and would not be able to propagate and evolve or get to the point of life, what we would consider life, very easily when we make that determination of what we're going to call life, and dropped on Earth, and suddenly it had like an abundance of what it needed, it would be able to propagate like crazy.
Yeah. So anyway, other people comment about, before we start talking about maybe going deep into abiogenesis versus panspermia, any other comments about life and
somebody made a super chat. Jamie Russell super chatted for 3, said phosphorus problem ? But I don't know if we're gonna actually be able to get into how are we supposed to describe here or decide here what life is? But I think we have a working enough of a definition that we'd be able to utilize for the sake of conversation, at least.
Well, at least,
yeah, I think so.
I would say at least on a carbon life form basis, anyway.
Yes, and the reason I say, well, could you have silicon rubber? People talk about that but just from the point of view of physics. Carbon is the most common element in the universe, and carbon's structure is such that it really can create all kinds of crazy chains and molecules. I mean, the whole area of organic chemistry is from the amazing things that carbon can do. Right? It's a very flexible atom given the physics of carbon.
It binds.
Yes. Go ahead.
I would say it binds with damn near everything.
And it forms interesting chains and compounds of stuff. So given some carbon, given some hydrogen, you start to do stuff. And then you throw in some nitrogen, some oxygen, some other things, phosphorus, and then you start to get some really exotic chemistry going on. That at some point it's better to talk about the system biologically than it is from a physics standpoint. When you get to be very, very complex molecules, the computation just to even determine how it is, the shape of it, becomes intractable.
It's like the protein folding problem. We're still not even close to solving the protein folding problem.
Yeah, I mean, from a quantum mechanics and theoretical principles, we can describe atoms, although the larger atoms get even more harder to describe, and we can describe some of the chemical bonds, but at some point trying to do it from first principles gets to be impractical and practical. And so that's why biologists have an advantage that they can look at things from a better vantage point, things that are quite complex, but underneath it still is physics. Right? And again, nothing taking away from biology, but underneath it relies on physics. So when you look at some of the stuff and you say, I want to talk about life, not how life starts, and ask, what about life elsewhere? And what about life coming here from elsewhere? or life starting on elsewhere on its own. Abiogenesis, you run into some interesting questions.
Wrote no last name for 5, speaking of interesting questions, said panspermia only pushes back abiogenesis to an extraterrestrial or extrasolar source. It doesn't, it still doesn't answer how life or proto-life got its start.
And I know it's going to make a problem, I think, go ahead.
I was just saying, that's true, but if the question is how did life arrive on Earth, it's still a valuable thing to discuss, right? Did life originate on Earth, or did it originate elsewhere? And if it originated elsewhere, we still have to answer that question, well, how to get that done? But we would still want to be able to recognize if that's what happened.
But I think Roden makes a point. I was going to make that very soon as well, and that panspermia does not really answer the question, how did life originate?
Right.
It merely talks about transportation of life, or the ability to transport the
necessary components.
The components to produce life. So when you talk about how did life arise, panspermia just merely transfers the problem to say, well, it came here from someplace else. How did it get there? Well, at some point it had to get there. And so there's an interesting question in astrobiology, which is, at what point after the Big Bang were there reasonable conditions for which life could have started? How soon after the Big Bang do you have conditions for life? We know from our models of cosmology and from observational data that, when you talk about 380,000 years after the Big Bang, the hydrogen, we had mostly hydrogen, maybe like 3/4 hydrogen, little less than 1/4 helium, and a fraction of percent or so of lithium, and that was about it, right? And hydrogen, helium, lithium is not going to give you the physical conditions necessary to create life. You needed to start to produce carbon and oxygen, at least from that standpoint. And even if you have other non-carbon-based life systems, you need to build those more complex atoms, and that required things like white dwarfs, things like massive, what we call tubby stars, giant stars that go supernovae and generate exotic things like neutron stars. Those neutrons collide and create all kinds of crazy stuff as well. So it requires stars to be formed and then stars to go into the end of life before you started even getting the atoms necessary to build the blocks for life. So the debate about when that happens is when that could happen is there, because in some ways we need telescopes like the James Webb Telescope to begin to explore galaxies in the process of forming, and to try to image some of those first stars that switched on, because between the flash of the Big Bang, 378,000 years after the Big Bang, when you had the microwave radiation, and the first stars, the universe was in a dark ages, right? There was essentially nil that was generating photons. The light from the early Big Bang plasma flashed out. It was at wavelengths relating to hydrogen and helium, and those have been red shifted all out to microwave. But at that stage, you didn't have really lumps to even begin to generate, to even form stars, to undergo fusion very much. And so the universe was essentially near a very, very dark place, except for the photons that were just taking off. So it took matter condensing to begin to form some of the earliest stars, and the galaxy that those stars were in, and there's a big debate about, did the stars first or did the galaxies first? That's things we're trying to figure out. But at some point you had to get stars, and those stars had to go on. But the earliest stars that were really massive had very short lives, went supernovae, started generating exotic things like neutron stars. You started having other stars that became white dwarfs and started doing their thing as well. And that's the condition for which you had the ability to generate the atoms that we think are necessary for replication, self-repair, and metabolism.
I want to shout out Smitty real quick, who figured out what I was drawing.
Nice.
Smitty asked, "Is that Red's rhetoric?" Yeah, busted. So, yeah, Red's asked me to work on a little bit of a design so he can have like a little avatar. So I made him a talking paper bag.
So the thing but again, back to the comment that Rod made. So panspermia doesn't really answer how did life begin, but it does give you a question about could life have come to Earth versus originated here. So any comments on those two things as to what people think might? I have some opinions, but what people think might.
Well, I have a. Oh, sorry.
Yeah,
go ahead.
No, go.
Okay, so one thing that I like to think about is kind of two things. One is I think that we're making pretty decent progress with abiogenesis, assuming plausible early Earth conditions. So yes. I don't think for that reason there's much reason to think that panspermia is how life got here. And the other thing I think is that taking now this is sort of a philosophical kind of thing, but if you take a look at the Copernican principle, which more or less says that there's really not anything special about Earth on like a universal scale.
Yeah.
Which if that's true, which doesn't technically have to be, but let's assume that it is. If panspermia is how life got to Earth, then that would have to mean that it's probably the most likely way for life to get to any planet. Most places with life, if that's the case, probably would have life that started elsewhere. And at that point, I start to wonder, like, okay, well, at that point, we're getting this question of this
where's
regression.
all the life?
Right. Where is it? Why is it flying around? Why aren't we constantly finding it or evidence of it in asteroids and whatnot?
Fermi paradox, right?
Right. It should be.
We say, where is it?
Right.
So it's you're saying that Copernicus leads to Fermi.
Well, the lack of demonstrable life outside of Earth is asked the question, well, why? Because one of the things that between when Enrico Fermi asked that question, not as a doubter, but where are they, right? The between now is that we from a planetary science view we have determined that planets are common as dirt. In our galaxy, given we've they're common it's a common thing. Given that we've explored let's say about around if you think about shell of about 1,000 light years and had some reasonable statistics around looking at finding planets around on stars within like 1,000 light years of the Earth, we can project that our galaxy of around 200 billion stars, Milky Way, has at least 1 trillion planets. That there are more planets than there are stars, and those are planets bound to stars. There's probably a bunch of planets that are rogue planets that are flying around as well, but at least 1 trillion planets around stars, and that's because it's harder to detect the Pluto class planets because they're it's hard to detect it, right? The other thing to think about is that if you say that those planets, those trillion planets, come in a wide variety of shapes, sizes, and conditions, and that's quite nice to see, because in that sense, it means that the combinations you can get include about somewhere around, I would say around 3% of planets have what we call the quote habitable zone, meaning it's not plasma hot, right? You can actually have chemical bonds, and it's not cryogenically frozen, where essentially you don't have much in the way of molecular action. But given the 4,843 confirmed planets through 2 or more methods around the shell stuff, we can assume that of those at least trillion planets in our galaxy alone, that somewhere around 30 billion are what we call habitable, meaning it's there, and of that, maybe 10 billion of those have been habitable for an extended period of time.
Would it make more sense to potentially, instead of talking about like individual planets, talking about like solar systems when you're talking about stuff like that, or talking about like certain kinds of stars that would be more or less likely? It's less, because then you're just going to be like, okay, well, we got to write off like so many planets because they're not close enough to a star. So would it,
or they're too close to a star and they don't have really the ability to have chemistry, and then unstable systems where the planet can't, because you want to have the ability, if your abiogenesis occurs or panspermia occurs, it takes time, and you want that planet to be a receptive platform for which that process occurs, and then you'd like it to be stable enough that it doesn't go off the filter. So having a planet highly elliptic orbit, having a star that has big eruptions that kind of scour its solar system with radiation is not a good way to, not impossible, it's not a good way to stars have life. So if you talk about what are, how, in our galaxy, if you ask me, to make a educated, estimate as to the number of planets that could be habitable for an extended period of time, enough for biology to do its thing, or panspermia to transfer its thing, I think the number is at least on the order of like 10 billion in our galaxy alone.
Well, also to the point of the stability too, it would have to be down to the solar system as well, not just the star itself, because as we already know and have witnessed, planets can vastly disrupt other planets, even at great distances.
And so what we look for, particularly when we talk about habitable planets that are very nice, is you typically want to have in that solar system some kind of Jovian heavyweight in a relatively circular orbit that tends to then circularize and regularize the rest of the planetary plane. So like in our solar system, if you discount the mass of the sun, Jupiter approaches like 80+% of the mass of our solar system is in Jupiter alone. And then Saturn has around 12%. And the remaining 8% is the rest of the stuff. But in our solar system, it's Jupiter and to some extent Saturn that established relatively stable orbits. Things that were elliptical got smashed, flung out, tossed into the sun, and so forth. So they end up becoming a stabilizing process, for which, if our model of how the Earth formed is reasonably correct, planetesimals accreted or came together to form the very early Earth. And having something like Jupiter around to stabilize things was also a helpful process.
So interesting. This is so much this is just so much stuff I don't know.
so that 10 billion. So the thing to say that's kind of different from maybe when Fermi was around, and when Drake first posed his Gray's equation. Gray is that planets are more common than stars, and in our galaxy there's probably at least 10 billion planets that are in reasonable zone for which chemistry can exist for an extended period of time, so that system can evolve, as Dr. pointed out. So they have the combinations there. The question becomes, well, is it more like, if you detect life on a planet, is it more likely that life started there, a biogenesis process, that is the physics did its thing and life formed, or is it more likely that life arrived there from someplace else? So what do you think? I got some comments on that, but what do people think about life someplace else? Is it more likely it started there?
All right, chat. There? 1 in the chat if you think life started somewhere else, and 2 in the chat if, what was the other option, Landon?
Started there.
Started there. Okay.
Yeah.
1 or 2. Chat, let us know what you think.
One is the is the panspermia, which is life arrived from someplace else. 2 is life started there in an abiogenesis way.
Okay, so we're getting a feel to be like, what does chat think? Do they think abiogenesis, or do they think panspermia? So 1 for panspermia, 2 for abiogenesis. I still think I feel like you would need. I think that with what Earth seemed to have from the get-go, that it would probably not work on its own, but have outside non-life effectively help create life. So it would be abiogenesis, but you would need outside stuff, right? So some stuff had developed outside, and then when it was like got dropped off on the way by, some of that extra stuff helped the stuff that already exists come together to be able to propagate.
Yes,
That's what I think. But like I said, I'm a goblin. The fuck do I know?
but before you dive into, because I don't want to bias people's things. I want to then start to talk about some of the issues and some of the discoveries and measurements, because people have moved beyond just the what ifs to actually performing experiments, and we're going to talk about some of those experiments.
Well, I want to jump in on this.
On the 2 processes.
And I want to jump in a little bit on this, on the whole origin thing on that. I think it's my belief, and yes, I'm going to use belief on this one, because we don't have a solid 100% bit of evidence for this. But I'm thinking Earth, during the late heavy bombardment, got a majority of what it needed. And shortly after, or during the late heavy bombardment later on, it got the rest of what it needed. And either it could have been in forms of stuff it was missing for the chemistry to work, or there may have been chemistry prior that eventually came.
And again, I think you made some very important points. And remember, again, let's step back and say, science is about questions. So the fact that we don't know is mean that's what science is interested in, right? And you raised some interesting discoveries and some models, right? If our model of how the Earth formed is reasonably correct, and data, we have mountains of data to suggest it is, then one thing that we know is that it started off about 4.8 billion years ago, when nearby star went supernova and sent out shockwaves, and those shockwaves not only collapsed a cloud of stuff, gas molecules, so molecular cloud, but also seeded it with some heavy elements. And then 4.7 billion years ago, 100 million years later, and part of that shockwave created lumps in that cloud, right? But that kind of like a snowplow hitting a pile of snow, it started creating lumps. Those lumps had the gravitational attraction started bringing stuff in, and 100 million years later, 4.7 billion years ago, another star went supernovae, gave it a slightly different element mix, and having a lump already, it really seeded it quite well with some heavy materials, and the resulting stuff in you and around you that's not hydrogen, not helium, and little bits of lithium came from those 2 events. The way that
it's the worst stardust.
Yeah, and then the protoplanetary systems, how sort of solar systems we see evolving, we see those things happening out in space in various stages. Earth probably started accreting because you've got some lump in orbital resonance. It helped the fact that Jupiter was there to kind of circularize stuff and get the stream going. But Earth started accreting, basically a pile. It's just a giant dust bunny rolling around, bringing stuff together. And somewhere in the 50 to 75 million years after the lump restarted another lump that was sort of Mars in size hit that proto-Earth, and the 2 vaporized and demolished each other. But the bullet, the big impactor, didn't have enough relative velocity to go through and escape, right? That it didn't have enough stuff to basically have launch velocity, and so the recruited bullet went through the two vaporized, and that bullet started off with a ring that lumped together to form the moon, and so you have Earth Moon, early Earth Moon, and particularly what happened with Earth that was quite nice from a biology standpoint is that that vaporized collision caused a lot of the heavier, denser materials to sink to the center. And so we developed a core that had a lot of the metals, as well as things like uranium, thorium, so forth. So we had a core that was relatively dense and relatively hot. And around that molten rock created a dynamo that generated a nice magnetic field. So even though you have this nasty sun producing all this radiation, that early Earth with this magnetic field started creating a bubble and shield it. And a lot of the high plasma radiation had sunk to the center. That center sinking, by the way, it drove a lot of convection in the mantle, which allowed it to be very geologically active. Continents began to form, move around, continents came together, back and forth, back and forth. So you had a fairly active stuff. You had lots of volcanoes, right? A lot of water that's in the atmosphere or on top came from volcanoes producing it. So Madame Pele right now is doing a wonderful dance on the Kilauea volcano in Hawaii, is sending out, many thousands of tons of water per hour, right, from above there. Now, water could also come from comets, other things as well, but the early Earth had a rich collection of molecules that came from those two supernovae 4.847 million years ago. So we got the carbon, the oxygen, nitrogen, all kinds of other good stuff there, sodium, potassium, so forth. So we had the ability to have chemistry, and with Jupiter stabilizing orbits and the end of this heavy bombardment where the thing wasn't basically, the surface wasn't being totally disrupted, you had the ability to have a stable enough platform with a rich enough environment that you had interesting chemistry. And so the questions about when that happened, when could you have a platform by which either life transport, because if life came to that early Earth, 10 million years after it formed, it's gone, right? If life came from elsewhere, it had to come to Earth on a condition where Earth could do something on Earth, or physics gave you the ability to generate the chemical soups to create life. And so that's probably, and this is here, it's quite debated, somewhere maybe around 4.2 to 4 billion years ago, we probably had a reasonable platform for which life either could come here and propagate or develop here.
There's a couple things in the chat that I want to grab. Rodent No Last Name for 5 says we've only begun filling in the middle of the Drake equation in the last 30 years, more like the last 15. The chat seemed to do a lot of 2s, so it looks like we got a lot of abiogenesis believers. We do have somebody, Jamie Russell said 3, God did it, and I think we can all agree that if he did, cool. We're just discussing more of a how. Red's Rhetoric asked, how much gold was used for the James Webb Space Telescope mirror?
The gold, it's gold, played on a beryllium mirror, and it's relatively thin layer of stuff. So I'll posit a guess that we're talking about something on the order of grams of gold. It's not a thick layer, because when you deposit gold on a mirror in a way that might be interesting from a jewelry standpoint, the surface of that gold is very, very lumpy. It begins to crystallize on top. So James Webb is primarily directed towards being an infrared telescope. And that's because of two reasons. They were interested in lower temperature systems like planets, and so their basically black body curve is peaking in the infrared and below. We're also interested in remote systems whose redshifted way from ultraviolet through visible down in infrared. So that's why the mirror is a general telescope is targeted towards primarily. Can see an optical, but it's primarily an infrared mirror. And I've seen in very, very thin deposits, when you start to layer gold atoms thick, a few atoms thick on a surface, it is some of the darkest, blackest material you ever see. And so I've seen samples of a beryllium mirror coated with a sort of mono or a couple atoms layer of gold, and it looks like black. Right? In fact, it's really odd because you look at it and it doesn't look like you can shine bright light on it, and the light just goes. It doesn't reflect enough for you to see, unless a piece of dust comes on it, and contaminate. It's in coating the Webb telescope, it wasn't very, very thick. It remains a very, very thin layer, so it's not a large lump of gold. I just haven't calculated it, but it's not. It's
not a ton. Rodent last name said, but how could panspermia life get through the flat Earth dome? That's the real questions. We're asking the real questions.
Well, there's a couple of so panspermia has a couple of different subsections, right?
Maybe the dome hadn't formed yet.
It's called radio panspermia, where essentially you have, let's say you have a system where you have life, and like the pressure from the star, radiation pressure from the star can push out bacteria or whatever, microbes, right? And the problem with that process, so the first thing is that you just got a lot of stuff, because if you go up the Earth's atmosphere 30-40 kilometers, you'll find life there, right? Life, even those giant clouds, the thunderhead clouds in like the tropics and equatorial systems will take air mass and loft it quite high into the atmosphere, and life can handle the cold stuff, a lot of life, so it doesn't die. So you can get detections of biological critters 40-30 kilometers fairly high up in the atmosphere. Once you get into outer space, there's not enough atmosphere for it to really be there. But the assumption is that, well, you could have life near the edge of the atmosphere and solar wind blowing it off to launch it in space. But there's a big problem with that, and that is that outer space is extremely hostile to life, right? And so you'll have systems where the DNA will be destroyed very quickly in the presence of ultraviolet radiation from the sun, and the vacuum of space will also cause even stuff, relatively, shielded stuff within cell walls to begin to decompose. And so the calculations kind of show that it's unlikely they can just take an aerosol spray of a bunch of even something as simple as the COVID bits of stuff from those viruses will in very short order, on the order of days to years within the system, be destroyed in outer space. In order to get something that is going to survive, you need an asteroid, make a meteoroid around a meter size, about a yard size. Inside would give you enough protection, because if you start putting it in small rocks, then you get the radiation from interstellar space, as well as radiation from the sun, as well as radiation from Jupiter and so forth, start to fry it. So you need, if you want to have something that's going to last a long time, because you're not going to have this beeline from A to B, you need about a meter-sized blob where stuff in the center can be protected enough. That's kind of the shielding you typically need. Is about a meter or yard thickness worth of rock to begin to protect something. The small bits are not going to work very well, and so cosmic radiation, ultraviolet radiation, vacuum of space, high energy particle stuff kind of destroys life. Even the so-called tardigrades, so people say, well, they found it there. Those things under the presence of outer space. Outer space is a really nasty place. That's this talked about those people thinking that Earth is somehow special, or the cosmic watchmaker created this special thing just for Earth. Well, no, most of the universe sucks in terms of being able to support life. It's just that we have a wide variety of stuff, a lot of it that we got some here.
That was another thing I was hoping someone would bring up, because the universe does suck for life. We just got lucky, and we're not even that lucky.
But in that sense,
well, even in
physics, the universe has such a range of conditions that there's some conditions there. Remember that of that trillion planets, at least in our galaxy, only somewhere around 10 billion have the general conditions for being somewhat comfortable for life, maybe.
And then it's like comfortable for life for biology, or comfortable for life for like physics, because there's like a whole chemistry.
Complex chemistry, right? To be able to generate some of the organic molecules, to build chains of atoms, to begin to have the ability even to do replication and evolution. Right. So the radius panspermia of the atmosphere leaks spores out, and those spores go out to there. The kind of time that takes to go to other planets in the solar system, let alone other stars, unless the thing is shielded by about at least a meter or yard of rock between the cosmic rays and the radiation from the star and the ultraviolet light and the vacuum of space, the life is kind of toast. Now, there's a different form that's sort of it's really called the lithopanspermia, which is a chunk of rock got transferred one planet to another, and we know that happens, that the rocks transfer, because we have rocks on Earth that are from Mars. We have actually meteorites we've confirmed are actually from Mercury, and likely from Venus as well. With Mars, it's so that you get an asteroid that smacks into Mars, and it's relatively light, about a tenth of the Earth's mass, and so rocks fly into space, and Earth is down there a little bit lower in the gravity well, and the rocks blast off from Mars end up hitting Earth, and we have lots of examples of meteorites here. I mean, not oodles, but we have examples of rocks from Earth, meteorites that landed on Earth that came from Mars. So we know that rocks can transfer back and forth, even coming from Mercury all the way up the gravity well to hit Earth. So we know that transport occurs. The question is, well, can stuff be ejected into outer space? And the answer is yes, right? You can get impacts where it escapes Mars velocity and escapes the sun's, it has solar escape, and it basically leaves the solar system. But if it's small and it's got life on it, it's going to be toast very quick. It's going to be dead. It's going to not be there. You need to have larger chunks, at least meter-sized things, in order for it to begin to be able to shield just from the transport of the stuff for there. But you have to, if you're doing this, you have to do three things. It has to survive being ejected from the planet. It's got to be able to then survive transit.
Well, that's how we know that it could get through the dome, right? The panspermia life came with. They brought the dome with it.
Okay, but hear me out.
That makes sense.
Here, so there, again, there are three things. It's got to be able to eject survive ejecting off of the surface of its origin. It's got to be able to handle the time to travel to the other planet, and it's got to handle entry back on the other planet. And so, when you talk about ejecting something, you're going to get a enormous amounts of pressure, right? That impactor enough to splatter things out and of Mars is going to generate, shock surface conditions that are between like 1,000 Kelvin and like 1,000,000 Kelvin. I mean, you get very, very high temperatures there, and the forces are extreme in terms of 3 million, acceleration of like 3 million meters per second squared, right? Huge accelerations that just take and flatten stuff.
Yeah, if anybody has watched Game Theory, Link's hook shot would kill him. For anybody, like, because you accelerate too fast, and he has no way to stop, and even if he did stop, his organs would get smushed into his body. So there's rules that it just would not. How does anything survive rocketing into goddamn space?
And we know that we have ultracentrifuges, we have railguns that can create those kind of conditions of something being blasted off of a planet's surface. And what we find is that any kind of complex life is destroyed. Those things, tardigrades could go there, or those the things, those things are dead. What can survive are some complex organic molecules, but a cell structure has a very, very difficult time if it's particularly on the edge of the material. You want to have like a rock, a big rock where there's biological material inside, deep inside, and the rock kind of protects it, and it has some sense. So it can kind of get ejected, particularly if it's simple life. If it's any complex life, it's destroyed. And then the transit, right? Because it takes.
Wait a minute. Wouldn't that mean Jeff Bezos would not have survived going to space?
Well, no, he's using an acceleration that's much more sedate than what you would get.
Yeah.
I was saying he was simple, but okay, fine.
Oh.
Yeah. Okay. Yeah. Because I mean, yes, it is. It is the thing that we're talking about, in terms of stuff that we're talking about things that are on the order of like 300,000 Gs, right? Rockets might subject people briefly to about 5 Gs or so, but 300,000 Gs, you're dead, right? You're just flat out. It's kill zone stuff. If you were inside of a meteor rock, even if you were a goblin, you're dead from just the shockwave of being blasted off, right? So
yes, there are rules for that.
Yeah. So even though extremophiles can handle the transit between the source and destination and planet, it's got to be shielded enough to deal with the cosmic radiation, the stellar radiation, the ultraviolet stuff, that atmosphere space.
There's certainly a lot of stuff.
Atmospheric entry, and then the final thing is you've got to survive atmospheric entry.
Right. That's not easy.
And that's a thing where even if you have rocks that survive, the outside temperatures of those rocks get high enough. When you see those shooting stars, so-called shooting stars, those meteors shooting there, you're seeing material being turned into plasma from the shockwave of stuff, and the chemistry there is gone. So you have to have a big enough rock, and then you have to have that impact set for there. So it is not impossible for biological material, or maybe even some RNA stuff, virus stuff, assuming that's life or not, or simple bacteria. It's not impossible for it to survive the eject, transport, land process, but it's not easy. It's not likely, and we can create those kind of conditions. So I would say, from the point of view of blasting rocks off to get here, it's theoretically possible, but it's unlikely that you'll get much in the way of transport just between Mars and Earth, let alone, let's say, Earth and a planet around another star.
But what if we have intentional panspermia?
Yes, and there's another thing, like if Earth, if folks here on Earth figure out how to build a spacecraft that could travel to the stars, then very likely we will, if we land on a exosolar planet that has somewhat habitable conditions, we will have contaminated that planet and begun spreading our stuff. So and you could say, well, they're either directed stuff like a space program, or a civilization that wants to escape the dying star or just explore their
ancient aliens was right all along.
That's certainly a possibility of stuff. But again, the process of transport is very, very difficult. It's going to be a challenge for humans to try to get off of Earth and colonize places beyond Earth.
Right.
In part because our rocketry, our systems are not designed to be separate from Earth. Even the moon program was just a bubble of enough water, food, air to keep astronauts alive, land on Mars, land on the moon, and come back. Right.
One of the things we got to do,
independent spacecraft.
We got to stop being squeamish about setting off nuclear explosives in space, so we can get the nuclear bomb drive, where you just shoot a nuclear bomb out your back, then it explodes, and you have a push plate. We got to stop being squeamish about that.
Why are we squeamish about that? Sorry. Before we answer, Alicia, for 2 months, member, bless, said aliens in space. Spacecraft, and then Res Rhetoric also asked, please explain how Conway's game of life is relevant to the origin of life question. Would love to hear your take.
I also got one more thing to interject on this.
Yeah, please.
Just remember, the Earth may not have been here at all because we did have a massive impactor that created our moon.
Well, and that's saying that if our model of how the Earth formed is relevantly correct, about 50 to 75 million years after the proto-Earth accreted from the planetesimals there, it got hit by an object that was about the 10th of its mass, and the collision of the two vaporized the two, resulting in both the Earth's core being, heavy materials being sink to the center, and the bullet impactor becoming a ring that accreted to form the moon. That's a system that seems to be there. Because one of the things that the Apollo 11 system did for us that was surprising was when they brought back rocks from the moon, we found that the material was Earth-like. It's very difficult, other than the exposure to radiation, that the moon surface was Earth-like, right? And that was kind of odd because the moon is relatively light compared with not as dense as the Earth, and the moon doesn't really have much of a magnetic field, and got all these. Doesn't have an atmosphere, and got all these pockmarks. That there was an assumption by some astronomers that the moon was captured, but we now know from the Apollo missions bringing back the rocks and analyzing it that the Earth and the moon share the same common chemistry, and it has that bimodal distribution of elements that came from the two supernovae that we can date 4.8 and 4.7 billion years ago. So with regards to the question about Conway's life, this is back to the question about what is life, and digital stuff to me doesn't have the requisites, the prerequisites that are necessary to define life. It doesn't have the basis of the replication, the definitions that we use, right? It to me, Conway's life or digital life doesn't have metabolism, self-repair, and replication systems that we think of. Yeah, you can fake stuff in digital things, but that systems doesn't, to me, qualify as life. If you start to have digital systems being considered to be life, you either have a very expanded view of what life is that could include a bunch of stuff you may not want to think, or you have a unrealistic view of what digital technology is. But I might be offending people that want to like put their brain into the cloud and live forever type of thing. I don't think that's.
Well, how dare you?
I have a take on Conway's life, and I think that an interesting thing about Conway's game of life is it is a demonstration of the principle of emergent phenomena, right? So you get things like oscillators and gliders and glider guns and things like this that can arise from these very simple rules. Because Conway's game of life only has a few rules. If a cell isn't next to at least 2 live cells, it dies. And then there's one, if it's surrounded by exactly 2 live cells, it becomes alive if it wasn't already. And there's all these, there's only a few of these rules, right? But from this can come these very complex emergent phenomena. In fact, because Conway's game of life is in fact Turing complete, you can play Conway's game of life in Conway's game of life.
And the thing about this thing that some people I think miss is that just because you have a complex system doesn't mean you have some watchmaker making it, right? Simple rules can create enormously complex and profound things, right? Out of a few accidents.
Yeah, I mean, I'm relatively simple, but the goblin's pretty cute.
Yeah, and that's the thing. So Conway's life has those rules, but even something as simple as the construction of a real number line that produces the wonderful things of numerical mathematics start from very few simple rules. So it doesn't take much for a set of rules and axioms to generate extraordinarily little complexity, right? So the fact that Conway's life can produce really amazing things like prime number solvers and other wonderful replicating itself type of stuff doesn't mean that there's a watchmaker. Just because you have basically the same thing. If you have physics, you have some matter, you have energy, and you have laws of physics, you can get extraordinary things. You get a universe, right?
Yeah. If you're gonna have to start having conversations about whether or not there is a watchmaker of sorts, whether or not there is somebody who has created or done or made things, then you're starting to exit out too much of the scientific fields and moving into the philosophical fields.
And I'm not being critical of Red's rhetoric. I think he asked a really good question, right?
Be critical of him. I think he'll survive. It's okay.
No, as I say, because again, science is about questions. It's not about answers, right? Dogma is about answers, right? And so he asked a really interesting question, and one of the answers got to be is that at some point, if you allow computer programs and AI to become life, you might get to a situation where your definition of life is so broad that it becomes meaningless.
Is it possible that we would run into something more akin to, we would not call it life, but we'd find another term?
Sure.
Like you would end up calling it like, listen, you're not alive anymore, but you now exist as part of the cloud because, listen, I'm the one that was offended. I want to be part of the cloud forever. Not if it was the Apple cloud. As long as it's not the Apple cloud.
People debate whether viruses are alive or not, right? And viruses can be fairly complex systems.
Real quick, guys, I'm gonna jump out of the voice. I'm gonna leave my screen up just for shits and giggles, but I'm gonna jump out because I got some other stuff to go do.
Bye, Nikki.
See you later.
Thank you for coming by. So just to have a complexity doesn't mean wow, right? It's because again, the mathematics and the number line and complex numbers and real numbers also has some extraordinary things in mathematics, starting from a few simple axiomatic principles, right? So it doesn't impress me when you say, wow, look at this big thing. it must be, right? People say there must be something magical there, right? It doesn't have to be that way. And that's back to the thing about abiogenesis, right? If you have materials necessary to deal with energy flow to create structure like cellular wall type things, and you have information flow, right? That is from a like a Shannon point of view, and you've got metabolism, and you have empirical replication, so you have evolution. You have the ability for chemistry to get to the point where you call it life, and that life to take off and do exotic things, given enough time and conditions. And so that's a thing that says abiogenesis is certainly something to consider, even though we don't know exactly how. Right now, as I understand from biologists, they don't have a really solid model of abiogenesis, and here's how life forms. Panspermia says you can get stuff going from hither to yon, but the process is very difficult, and we have a number of conditions where we know it's not going to survive.
So are we gonna like Hitchens razor this and be like, well, or not Hitchens razor, the what is the most simple answer?
Occam's razor.
Occam, thank you.
I'm sure Hitchens would have a razor too, honestly.
Probably.
But if you had, so if I had to vote, I would vote 2 rather than 1, simply because we have existence that physics can give you life, for example here, and we have lots of platforms on which chemistry could do interesting things if it gets started, and we have lots of time. So when people ask, do I believe in extraterrestrials? Well, and I tend to not like to answer that question because I think it's a bad question, particularly because how I believe doesn't give a damn. I mean, the universe doesn't give a damn about my opinion. Right? The universe is going to do whatever it does, whether I believe it or not. Right? So let's take belief out of it, and instead say, would I be surprised to discover that Earth is the only place for life in the universe? I would find that shockingly bizarre. I would find it very, 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 very improbable that Earth is the only place in our galaxy, alone in the universe, where life exists, even intelligent life. And we can then explain the Fermi paradox. Well, how come we can't just have conversations with these things and get regular visits and so forth? That has to do more with the problems of
recognizing life and relatively. I like how you're answering this question about let's talk about biology and chemistry when it comes to life. In the end, you're answering it with physics.
Yeah, well, I said I'm a physicist, right? So
oh no, I love it. I love it. It's perfect.
Biologist.
It makes complete sense because it's such a convergent point. It's such a I don't mean like a point as in an argument. I mean a point as in like a point in time or a point in discussion, that this trying to decipher where life can come from isn't just about chemistry. It's not just about biology. It's not even just about its geology. It's astrology. It's
I think you mean
astronomy. I mean, it's probably astrology too. I don't fucking. Was the person who was doing the research that day a Leo by any chance? Because that would be kind of problematic.
Yeah, but the thing about Drake's equation and trying to estimate the number of intelligent civilizations in our galaxy, as an example, one of the things structures you have to say is that, okay, let's say you have life, that life evolves to be complex enough that we could detect it from here on Earth, right? Because it gives off radiation we can detect, and it's not it's not lost in the background, and it has intent and information transfer, or so forth, all those sort of things. It's not just static. The question then to ask is, if it can rise to the point where it can start to announce its presence, by sending out light, radio waves, gravitational waves, whatever the mechanism is. How long does that civilization last, right? And the universe says it's not forever. You don't live, that civilization can't live forever in its current condition. The star that's next to will doom it at some point. So if life is going to go beyond the lifetime of the solar system, it's got to be able to get someplace else, right? And so you have to think about how long can a civilization last? And so, the third essential form of astrosociology says, how long can a civilization last? Does it develop something where something happens where you get some super deadly bug thing and everything dies, right? Does it happen where you get some big giant rock that smashes it, or the star goes blast and scours it, or there's a nearby supernovae and gamma ray burst that just fries it? How long does it last, or how long can the civilization last without destroying itself? An example.
There's only so much resource, yeah.
I've asked questions about religion, right? Is religion, if you get a civilization, is religion one of those things that civilization tends to develop, right? Is that kind of a thing that you sometimes get, right? And if the answer is it's common, right? Not just happen on Earth, but any civilization would also develop religion. Then you have to ask, well, is that religion going to distort reality enough in the minds of those people to cause them to do something stupid like destroy themselves?
And I mean, we know that's
certainly
happened. People destroy themselves over religion all the time.
Religion and cults have the power capability, if they somehow infect enough of the populace that has enough capabilities, to destroy the civilization, right? We see that. We see those capabilities that are there. And so that's one of the questions. Well, even you have to ask about, if you're having people, essentially exploring space and trying to colonize other places, can the civilization, even in a small spacecraft, last long enough to get there, right? Or do you have to put them in suspended animation and reanimate them and hope that everything works out? It's a big question. I don't know how long. What's the half-life of a civilization? We don't have a good data, because we only have one example that's lasted for, and then for stuff. And if you talk about Earth civilization being detectable as intelligent life on other solar systems, we've only had maybe 100-ish years or so of emitting radiation that someone might be able to detect that's more than just lightning and zapping stuff, that there's some information being sent out there in outer space, because radio systems have only been going for all of a century of stuff. So
it's a very short amount of time, especially even given the amount of time life has been on Earth.
Yes.
And on top of that, or life that was able to start communicating.
And you have to come back to say, assuming that general relativity is correct and it survived many tests, that says that the signal of detectability of life in signals from life from Earth is only 100 light years wide. Now, other civilizations might be able to look at the spectra of our atmosphere and detect the exotic chemistry going on there. So there might be there could be civilizations much farther away from Earth that have looked at the atmosphere of Earth and say, look at all that organic chemistry, all that biology going on in Earth's atmosphere, right? If they got good enough telescopes and so forth. But but for the majority of Earth's life, they would have said, yeah, there's some critters going around there on the surface of the planet. Isn't that cute? It's only been 100 light years-ish, over 100 light year shell, that they would be able to even detect that there's information coming out from Earth that would suggest our intelligent life.
Right.
Even though we've lasted for long. So to have intelligent life, and then have the ability of intelligent life to announce itself.
Yeah, we have to be lucky enough to get it at the same time.
I think another concern is that increasingly human communication is not being broadcast across just a wide beam electromagnetic thing. We're increasingly using things like narrow beam transmissions and fiber optic transmissions and things like that. So humanity as a humanity as a detectable species, despite the fact that we're probably not within a few hundred years of going away as a technological species, our detectability is starting to fade already.
Yeah. Now, that being said, and you raise a good point, that some of the early transmissions of TV broadcasts of "I Love Lucy" and that sort of thing, it would be detectable to now. It's the internet and encrypted things, but one thing that's nice about the other side of that argument is that even with encryption, where you're tunneling and you're trying to keep it opaque, that encryption still has structure. There still is metadata there saying what it is and where does it go next, right? It's got to have some ability to have some information detail, because we're not just sending out random signals on the internet and waiting until something happens. Even encrypted channels have something, right? And even if they're going through optical fibers and shielded, that shielding is not perfect, right? We were able to detect communication of optical cables from an embarrassing distance away from an optical cable. Let's just say that can be done. But even more so, the power grid that you have to distribute power, or even if you don't have a distribution of power, local power generators are ways of announcing themselves. The Earth is very noisy, and it's that even if we went to all pure digital and optical fibers and no longer had aerial TVs and that sort of thing, the electronics and the digital noise that occurs is significant. Something as simple as a modem, that LED that you see on a modem that shows network activity. If you're clever, you can actually determine what it is the modem is transmitting.
Well, I think that a lot of people,
how the light flickers.
Yeah, I think a lot of people don't realize how much information is readily available if you know what you're looking for. And I think people get a little freaked out when it comes to psychology about, hey, you can tell a lot from a person just by they're like, hey, this is my favorite song, right? And so you can listen to that song and be like, okay, I know way more about you than I ever needed to know, but at the same time, it's
called
only
advertising and marketing.
Right, exactly.
Marketing. That's so even if you have a system that's completely encrypted with strong crypto stuff, the metadata that's necessary for having information transfer is still detectable. So we might see a civilization where we can detect its power generation and we can detect the metadata, but we may not be able to deduce the encrypted payload, right? But we'll still be able to detect that there's something beyond lightning strikes and volcanic eruptions and other radio emitting thingies. Even if we may not be able to understand the detailed information, we can detect there. In fact,
right.
One of the things that experiments I did before I left in Silicon Valley was to develop extremely precise random number measurements of randomness or degrees of randomness, right? And we're able to show that encrypted data is very rarely random. Most encryption systems, you can distinguish encrypted data from a pure random source, even though you don't understand the structure, right? That because encryption is not random chaotic stuff. It's very precise stuff, probably so you can decrypt it, right? And it turns out there are interesting structures involved in that. So it's not impossible to deduce by cryptographic analysis what it is, but you can very easily detect on a network flow of encrypted information, and if you're clever, you can actually even deduce the algorithms that are being used around the outside.
Yeah.
And if they got flaws or you've got capabilities, you could then try to attack the payload and eventually break it apart, right? So it's not impossible, but a intelligent civilization that's super privacy oriented, encrypt everything, really advanced crypto stuff, will still have enough structure in its information. Just the presence of a bits, right? If you're sending encrypted data of, let's say, zeros or ones, or however they do their encoding, that encoding alone is enough to be able to be detected to say it's intelligent life, even if you don't know what they're saying.
Right. Because you might not be able to translate it, but
Yeah.
it exists.
And that's the thing. The Rapa Nui, the people of Easter Island, had a language, and we have 3 chunks of stuff that has this kind of alphabet. We don't have enough to actually decode it, and thanks to the Catholic Church and a couple of FWAD priests who decided to burn all this heathen stuff, we lost that language. Even though we have evidence we can see the symbols,
we know
just don't have enough information. And we know that it's intelligent.
Lungo, by the way.
Yeah, but it's at last it's lost. So we might get glimpses of stuff. I mean, maybe, for example, you've got some star that another star passes right in front. You get a micro-lensing effect where due to relativity, it's curvature of space-time, you get a focus of stuff from that back star, and you get a brief, really intense bunch of data, right? You may not be able to decrypt it or understand it, but you should be able to see the structure above background if you're good enough, and if the signal doesn't degrade and on. So detecting is okay, but having a conversation is not. It's probably not. And here's the other thing. The sad thing is, I think it's fairly plausible to state that anyone living right now listening to this broadcast will not live long enough to see a two-way conversation with a civilization outside of our solar system.
I don't know, Landon. I'm at 150 million and going strong.
Assuming that okay, with Stafford dinosaur being an exception. Assuming general relativity is correct, and assuming that you're going to live, pick your lifetime, right? 150 years or 100 years, however long it is. You have to, in order to have in your lifetime a minimal conversation, you have to have that sort of hello out there being received, and they turn around and say hi back, right? That ping pong thing. And relativity says that if you're going to live another 100 years, you've got a 50 light year shell that you can do the forward and back thing. Right. And given how much we've scanned around the 30 to 50 light years, it's highly unlikely that there's a intelligent civilization that we have this conversation with so far. Now, it's not impossible, but it's very improbable that you will live long enough to see a Earth to civilization on another planet, extrasolar planet conversation.
They'll have to have already received it, essentially.
Yes.
And it would have to already be on its way back.
On the other hand, the good news is, given our ability to detect signals, telescopes and so forth, and do more and more, better detection stuff, it is reasonably likely that in your lifetime there will be planes of detection of life outside of Earth, and it may be within our solar system, like on Europa or Mars or Enceladus, things like that, or it could be signals from farther away, that we receive and say there's something going on there. Or it could even be something more simple, like we can get the James Webb Telescope to look at do a spectral analysis of an atmosphere of a planet around another star and see really exotic chemistry going on. Those are things that are quite possible. So, early detections of life outside of Earth are probably going to initially be controversial. And some of those will be rejected, but I think it's likely in your lifetime, given progress, that we will, like black holes, go from it might happen to, well, maybe this is a black hole, maybe not, to, oh, it happens, oh, we can image it, and oh, there it is, right? There's lots of stuff. So just because we're not listening to civilizations now doesn't mean that it isn't possible in your lifetime to begin to detect signals that have been coming towards us for a long time.
Yeah. That's the other thing.
But to go there, sample life, have exchange of stuff back and forth, it's improbable that you'll live long enough to do that, except unless relativity is incorrect, or you live for an extremely long period of time, or we've missed something obvious. Those are all the caveats.
So we have a couple more questions. What is your opinion of breakthrough star shot? ? With lasers.
I'm thinking about this is part of process of how can you get a spacecraft to go long distances in a reasonable amount of time, right? Spacecraft like Voyager are going to continue, just due to simple physics, continue to go for a very, very long period of time, and that they might eventually hit something, but they're going to go for they're going to travel in space much longer than Earth is habitable. But there are people say, well, let's get to stars, other stars besides our sun, in a reasonable amount of time. And so one of the there's various things that people think about, which is using light pressure and a laser to kind of push along, to carry nukes and go boom, boom, boom off the back. There's a number of things that people are talking about, all these star shots, to be able to get to a star in some amount of time. And that's certainly one of them. One of the light sails, or directed lasers, or ram scoops and fusion drives. I mean, if I were to try to bet on a technology to be able to have a machine go for a long period of time, I might look at the scoop up interstellar hydrogen enough to condense it and shove it into a fusion reactor, generate power from that reactor, and use that to then accelerate the exhaust out and push you forward. Right? That would be the method right now, I would guess. But there's many other methods as well, and really smart folks and clever folks that are working on these starshot things are doing some important work, even though it's out there in the future. It's if life on Earth is going to survive beyond about 1.5 billion years from now, it's got to be able to colonize someplace else, because that's kind of the time frame for which the sun, starting to as it evolves, will start to make Earth somewhat uninhabitable, right? This is before it goes to a giant phase, right? For 4 or 5 billion years, but somewhere around 1.5 billion years, loss of hydrogen and so forth, the Earth turns into basically a desert with polar caps, which life can kind of continue going on for a while, but it won't be a very nice place. And by the time the sun goes into a red giant phase, Earth is toast, literally. So Earth has got to survive. Life has got to survive on Earth long enough to be able to figure out how to transport itself to other planets. And to do that, it's got to do so without being tethered to Earth. We can't have a spacecraft where we keep going back and forth, handing it supplies, right? It's got to be able to have its own system and go for a long period of time to get there. Now, is faster than light travel possible? I don't understand the physics that would allow you to do faster than light travel. And we don't see evidence on Earth in the universe of that happening. I'm not able to just understand how it's possible. So I will say, assuming relativity is correct, we've got to have spacecraft that has a power source, because you can't rely on sun power. Even laser beams from Earth have a limited ability to push things out. You can accelerate things, but the problem is you got to if you want to go someplace, you got to deaccelerate, right? All that speed you end up going forward has to be undone. If you're going to arrive at the other planet or orbit on another star, you got to slow down and not to go zip by and say, "Oh, there was a star."
So why is it that why we're like nay to nuclear booms in space to make us go fast forever? Because that came up and I wasn't sure what is our issue with that. I'm sure there are. I just don't know what they are.
There is currently a treaty that prevents it, in addition to the logistical problems.
Yes. So there's treaty, there's logistical problems. There's also there's some issues going on where you say, okay, launching a nuclear device into space, and looking at the launch failure modes. First of all, what happens when that launch fails, right? How do you deal with the nuclear device and its reentry?
Because a failed launch usually involves an explosion.
I imagine the treaty is, who are we allowing to be responsible for letting a nuclear launching device exist in space that is not going to just shoot it at people they don't like?
Basically, the treaty just says you cannot put nuclear devices.
Right, but if we were going to allow, but if we were going to allow it, who would we allow to do it? I feel like it would be Canada. I feel like it would probably be Canada.
Well, I mean, the thing, I don't know. I mean, I think if Canada did it and made a mistake, they would say sorry in a really professional way.
That's true.
I think so.
But saying sorry may not be good enough, right?
My thing with Canada is it's too far away from the equator.
I'm just
good
thinking
launch sites
that
are near the equator.
Right, but that's like the device is already in space, so they're going to be launching from there. But what I'm saying is like what country?
Canada can borrow some.
Right. What country would we? I mean, we've been borrowing America since Apollo. But
Canada makes a deal with France. I mean, maybe give them Quebec or something like that, and then launches from a French site.
Yeah,
down the equator. I mean, ask politely somebody else has a tutorial thing and so forth. But kidding aside, so the primary method of powering spacecraft beyond Mars distance, where the sun gets weaker and weaker, right? By the time you get out to the asteroid belt, let alone Jupiter, the sun is really too weak to be able to do effective solar power stuff. Is you send it up with a radioactive blob that the radioactive decay can generate heat, and you use that central heat called the thermocouple to generate electricity. So deep space probes have a blob of radioactive material that's decaying, and you use that energy from the decay to power the spacecraft. That's not a nuclear thing. The treaty says it talks about having nuclear devices capable and doing nuclear detonations in space. And the other thing to understand is that having a massive, let's say, thermonuclear device detonate in space is not that exciting. You don't have an atmosphere to create a shockwave to do all the stuff.
So it's like way less entertaining. So are you saying that we might be more willing to do it if it looked cooler?
Well, but I mean, even taking a nuclear device and landing on an asteroid and having it go boom is not that big of a thing, because the lack of an atmosphere to generate a shockwave. Yeah, it'll keep the thing, radiate the thing, and spray off some stuff, but it's not the spectacular sort of things you get with the mushroom clouds here on Earth. nuclear detonation.
Well, now we know why America's not going to do it, because America wants the spectacle. Right.
I mean, setting off a nuke in Jupiter's atmosphere would be really spectacular, right? For stuff. But of course, it wouldn't mean very much because Jupiter is so radioactive anyway. It's just like, yeah.
It's just like a normal day on. This is Tuesday on Jupiter.
So if you're trying to generate, there's other ways to generate radiative pressure than to have a nuclear device, and there's only so many of those you can have on the ship. And remember, if you're going to go from here to there and arrive there, not just fling past there, all that momentum you build up has got to be undone. Otherwise, you face plant into the thing, and you're.
So the question is, how do you stop?
Gone,
right.
Yes, and so one of the problems is you have to expend same amount of energy of use to speed up to slow down, right? So if you send a star shot with a laser that's really focused on it, and you're somehow able to get a light sail to go up fast speeds, the question is, how do you slow down on the other side without somebody having the laser going the other way to slow you down?
The brakes are just a nuke going off.
and even there, like, how many nukes can you have? Because the mass of a nuke is not very much. I mean, and you say, what do you mean? So, well, if you look at the nuclear artillery shells of what it takes to the suitcase nukes, but even if you have one of the big honking nukes of the 1940s, that mass is not very much. Because remember, presumably you have some spacecraft that's big enough to have some biology and food and water and all sort of stuff going on. You're not talking about a tiny thing, right? Things like New Horizons probe was a very, 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 very light spacecraft launched on one of the most powerful rockets of the time we had, and its model was zip by Pluto and say, picture, done, right? So why is it important? Even if you use a laser to get it going forward, you have to reverse. Now the problem is, let's say you have you put on rocket fuel and say, we're just going to turn it around and put on the brakes. Well, now all that mass you need to expend to slow down is mass you have to launch with. So now you have to have extra fuel on board to launch the fuel that halfway there you need to turn around and start slowing down.
Space is complicated, man.
Or you go very slow and you take 1 million years to get there, and you have getting to Mars is easier mass-wise if you take a long time to get there. If assuming you want to land, right? If you just want to go smack, then that's fine, or zip by and say hi. But if you want to slow down, you've got to. So, and it's even more so if you want to land there and come back, because now you have to have the mass to get out of Earth's gravity well, and then you have to have the mass to slow down to land on Mars, which means that mass has to be launched from Earth. And then you have to be able to get mass to launch off of Mars and then slow down and not face plant on Earth, right? So it ends up becoming a lot of the stuff just to get a little bit stopped back, which is why it's been so difficult to try to do these return missions of Mars material, right? We've got a rover now with some capsules with small chunks of Mars that eventually has a thing where a rover can come down and pick it up and return it back to Earth, maybe sometime in the next 15 years or so. And that's going to be very difficult just to get a couple of samples of stuff back, right?
This is advanced resource management.
So when the fraud of Elon Musk's hype machine says he's going to get to Mars by blah, 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 and $100,000, all this Hyperloop stuff, right? It really does a disservice to serious people that are seriously trying to solve this problem. And the experiments we've done in the International Space Station, people that are looking at advanced rocketry, all this sort of stuff, is a difficult task.
I love when Landon throws
in the moon is relatively easy.
I'm honestly surprised that Elon has proposed a Hyperloop to Mars. I mean, why not? It's just as realistic.
Yeah, I mean, I'm throwing hype. I disrespect his hype machine
That's duh. I love it.
The area of robotics is a really serious thing,
And
done
it's
in disservice
complicated.
by a politically stunt, right? The area of transportation is a serious thing, done disservice by his hyperloops and his solar roadways and his exotic trucks that are going to eliminate, trains, all sorts of.
By being less efficient than trucks, somehow.
Yeah, it's sad that even though Musk has a lot of interest in interesting things, that much of what he broadcasts is hype. It's almost
not serious, yeah.
Almost bordering on allegedly fraud, right?
Do you remember when
not very serious.
Remember when he was going to replace roofing tiles with solar panels, and that just nothing ever happened with that?
Yeah, well, how would you even?
And his Teslas that were you going to be able to make all the money back on the spent on a Tesla in 1 year by bringing out as an automated taxi that's going to happen all this time. I wish the press, the next time he comes up with one of his hype machine things, to say, why should you believe you now, given this didn't happen, this didn't happen, this, and even if he goes back and says, well, I had a SpaceX, right? SpaceX is a taxpayer subsidized system for which the cost of sending a kilogram into low Earth orbit is as bad, if not worse, than the space shuttle, right? And doing something like, well, he sent a car out in outer space. Guess what? They were doing that in the 60s. Doing something in the 1960s that 50 years later does not give you a wow, you're being really innovative.
Yeah, there's like a degree of how much of him is just media, like you said, hype machine, or how much of it is just marketing versus how much of it is actually viable. Right, so there's like, I feel like this needs to be a whole conversation that we have on a, like, for sure, at some point.
Have it throw shade at Elon Musk.
Check out on Thunderfoot, who does really good analysis of the Musk hype machine. The problem with, and I hesitate to say this stuff, is that the cult of personality that Musk has fostered and enjoys will attack us for stuff, right? That's a sad thing.
Chesh, you don't want to get attacked on the internet. That would be horrible.
Shit, no.
And there's the same sort of thing with all these sort of UFO conspiracy people and so forth. That's another problem that occurs in trying to have legitimate searches for extraterrestrial intelligent life and so forth gets clouded by that stuff. And so we don't need hype creators and cult creators of stuff.
Yeah, there's like the thing is like it is important to get people and investors and just students and children, everybody interested. And then there's the point where you've taken it too far, right? And it would seem to me that the way Musk has gone is like, it started off decently, like getting people excited about space again, great, and then now we're in left field where you're just a media man that doesn't actually provide as much as you claim to. You're more of a politician than you are a scientist at that point,
or a marketing person. So I wish the press would say Elon Musk, perpetrator of many prognostications that failed to come to pass, has yet again tried something else, right? But back to the thing about life stuff again, there is very serious science looking for life, trying to understand life. But there's cults that talk about being against evolution, or being for a creator, or being or saying that the government and the powers that be have hidden the evidence of extraterrestrials and all this sort of stuff.
Big astronomy, man. Big astronomy.
Yeah. I mean, we would love to be able to find that. I mean, there's a lot of serious work going on trying to find this stuff. And it would be lovely if one of those totally intelligent systems that might exist out there comes by here and has a conversation. That would be wonderful. But I'm not holding my breath.
Yeah, hold on. Why is this all our responsibility? Why can't they contact us instead? Like, come on. Give us a break.
most likely, if there's some, again, let's assume relativity is correct, and someone's on their way to arrive at us, they've got an object which might be detectable at some point, just from the thermal signatures, let alone the emissions that come from them, right?
I just imagine that politically that would be a nightmare, like a complete nightmare. So if we didn't discover someplace else or somebody else or something else first, and then be able to process that information and then how to approach it, if it just was like hi, and we would flip out. We everybody would be losing their damn minds.
Yeah. In the likely event of detection of life outside of Earth, the process will just be revealed as it is. You won't have people in black suits coming in and saying you can't say that, blah blah blah. It's like it's gonna happen, assuming it does. And it's a shame that the cult of that sort of stuff is so pollutes this thing, and even channel like History Channel don't do science technology a favor by doing their exotic. The Egyptians couldn't have been smart enough to make the pyramids. We have to have aliens do it for them, right? That's wrong, right? This kind of stuff that's done. So focus on facts and help out the process of stuff. If you want to participate in things, SETI, Search for Extraterrestrial Intelligence, is a very credible group that you become a member of. They have things you can do to help in things financial and using your brain to help them and stuff. They're a good group to go and link up with. And there are other Illuminati. Yeah, and would if Illuminati were really that powerful, there'd be a bunch of other things I'd like the Illuminati to do.
Come on, guys.
Listen, guys, we got a list here for you. See if you could take care of that. That'd be great. Yeah. Thanks.
So my I think about abiogenesis. I think works, and I use that as an example. It happened. I believe it happened here on Earth, because I think that panspermia is implausible. Mm-hmm. It's unlikely. So if I just have to do the odds, I would say that abiogenesis has order of magnitude more plausibility than panspermia. And even panspermia at some point has to have abiogenesis somewhere to begin, right? Because I think it's a very credible claim that shortly after the Big Bang there was no life, even however exotic you try to do it on. Even if you say convoid life is life, there's at some point the question becomes, when could the universe have actually had a case where you have to have some abiogenesis somewhere for the first life to form, even if panspermia then goes all over the place, right? So I think as I see the data right now, panspermia is not that plausible where abiogenesis is. And I had a evolutionary biologist, gave me a weigh in on that, and she said, we look at the tree of life, right? From the basically the sequencing to be able to determine the origins of life and how the tree of life formed. And we have yet to find life on Earth that has a different root.
Yeah.
Right.
All DNA that's been sequenced on anything, and we haven't sequenced everything, right? So it's a small fraction. Keep showing another branch of the same tree of life. I would think if panspermia were really kind of common and quite likely, it would be from some place that has some abiogenesis in a couple of spots that might have some differences, so that when they arrive at Earth, we get this exotic tree with multiple roots. Assuming that's DNA sequence. Even if you have viruses, right? The virus sets we see are Earth biological stuff. We've never detected exotic life on Earth. By exotic meaning, exoplanet stuff on there, and they've been looking for it. So, I
think
so that's one of the arguments.
The only way that I would find, given like first developments in science, for me to come away with panspermia is the likely way life got to Earth, is if we discover that we have a whole bunch of plausible, really well-established mechanisms for abiogenesis, but none of them can happen on Earth for various reasons. Every option that we can come up with, for some reason, is precluded by the conditions that we expect on early Earth, but not precluded elsewhere. Then I would say, okay, well, in that case, panspermia becomes the more likely option, but that does not seem like the way the research is going. It seems like we're actually making progress using plausible early Earth conditions as our starting point. And since that's the case, it just seems like panspermia is becoming less and less likely.
Yes. Now, again, I'm not saying it's impossible, but I think if I had to make a plausible guess, if there was panspermia, the place it might come from is either from Mars, likely from Mars, because the transport problem is one issue. Now, it also could be from comets, but the problem with comet stuff is that it's got to basically get to the comet from a very, very long process, and it's that time thing that makes it quite difficult to hit. So if Earth life was panspermia born, then the more likely source would be from Mars, where we know Mars had early on, oceans and things that seem to be pretty well established from the probe data. We haven't found solid evidence of like fossilized Martian life yet, but there's a plausible chance that we might eventually find it if it's there. I think it's more likely the case of abiogenesis process, and the biologists that are working on stuff. There have been recent developments in creating artificial life where they've created cell-like structures that don't have metabolism but have sort of containment stuff from non-life forms. They've done some interesting things recently, and that's one of the areas of research is, if abiogenesis is possible, do it. Is the ultimate thing. So and they're working on that. Right? That's being explored. So we're getting better at detecting signals. We're getting better at scanning the universe. We've got probes designed for Mars. We've got probes designed for Europa. If there isn't life on Mars now, the second place outside of Earth I would look is underneath the ice on Europa, which is a moon around Jupiter, as a sort of like my number 2 nearest candidate for things. I don't hold up much credible stuff of the molecules detected in Venetian atmosphere as evidence of life on Venus. Venus does not seem to be very habitable, and Mercury is even worse in a different way. So Mars and Europa are kind of two leading things where he had to go. If it wasn't Mars, and it wasn't Europa, then I'd try Enceladus, which is the moon around Saturn. And if it wasn't there, then you got some other possibilities of things, but it gets to be harder and harder in our solar system to find sources of life. At that point, you're probably now having to look at habitable planets around other stars besides our sun. That being said, detecting life through telescopes, radio telescopes, optical telescopes, or gravitational thingies away, that's certainly quite plausible in your lifetime given progress.
I like it.
And the first detections will be guesses. Some of them might be refuted, and then they'll be controversial, and then eventually, if things go the way to assuming it's there, right? One of the goals of search for extraterrestrial life intelligence is to not discover something that isn't there, right? That's the problem. Is we've had cases where radio telescopes find a weird signal, and we find it's actually a reflection in the atmosphere, and it's someone's microwave That's, stuff like that. So scanning for really weak signals, we probably want to put radio telescopes on the far side of the moon, because Earth is a really noisy place. Be able to do deep scanning of the universe using the moon as a shield, because Earth is quite noisy. And as people like Musk put up useless satellites in low Earth and begin to ruin your nighttime sky, we'll need more and more the moon platform to try and escape from some of that stuff.
Right.
By the way, I'm serious about that. Pay attention to the nighttime sky when you get clear skies.
Yeah.
Go out of the city as well and see the nighttime sky, because the way the trends are going, at some point that beautiful sky system is going to be full of all kinds of dots and things and flaring micro things, going from people like Musk putting up a relatively useless network transport system and not giving a damn about.
Are you saying that capitalism is ruining the environment? Is that what you're suggesting?
Well, I think people perpetrating what appears to be fraud, in my opinion.
Ooh.
All the allegedly stuff.
Government-backed fraud in many cases.
Yeah. So that's the thing. Is I'm serious. It's likely 10, 20 years from now, the next generation of kids won't see the kind of nighttime skies you can go out to a park and
even I don't see the kind of sky I used to be able to see depending on where I was. Like the northern lights, can't see those anymore. But I think we should probably look to wrap it up here. A little bit of sass thrown at Elon Musk. I'm here for it. It looks like the winner of the Versus today was Abiogenesis. Panspermia, though interesting, does not seem to quite have enough to be able to keep up with.
It's plausible but unlikely.
Yeah, so it's not quite there. Not quite there. Dapper made a really good point about if we did decide that life, I think that was probably the best argument that would tip that scale, is that if we were able to decide or decipher that life was not able to happen on Earth but could happen elsewhere, that would tip the scale, I think, for sure. But what's everybody got going on before we get out of here? Yeah, go for it.
I sort of apologize if you're an Elon Musk cult fan. I'm sorry that
Don't be sorry.
Mad. I was just expressing my opinion. Sorry, Trademark Canada. And also I apologize to the biologists who know a lot more about this subject than I do, from a biological point of view. Other than that, I'm trying to develop a channel called Our Favorite Universe. Thankfully, my producer has survived getting COVID from a COVIDiot, thanks to the wonderful healthcare system that's in Canada, where healthcare would be a more of a right than a privilege. I know that sounds odd to an American, but that's the way it is. So he's recovering, and we actually have plans now for my putting out what I said I was going to do.
Good. Let me know once it's out, or when you have a link to it. I'll put it in the description down below. So if you're ever watching this in the future, hopefully that link will be in the description below. We talked about a few other things that you could support that will also get linked below once this is over. This is going to be my happy Halloween picture for Halloween, so I hope you enjoyed my little sketch of it. Dapper, what do you got going on?
I also like, by the way, your Res Rhetoric bag thing.
The angry paper bag.
It's kind of like Hideous Bob, but American, not Canadian. From your South Park reference. I do have a Discord channel, and so I'm wondering if I went and generated and on the Discord channel, there's a science news thing. There's a thing about cooking and eating, medical science, history, disasters, and a news feed of just news events of the day that I find amusing. If I sent a invite link out,
yes.
This is good for 7 days.
Yes.
Let me just send that to you. If you go and join that link, there's an invite link. I will put you into the science fan category, and there's the link. My favorite universe. You can post that there and then join. Again, I do regular updates on science. Right now, there's a whole bunch of stuff about the Kilo volcano and the eruption and data
really
and images and lava pour and stuff. But there's also all kinds of stuff about science and space and things like that, and occasionally cooking, dining stuff. Bunch of medical things, and medical things not that are focused on like peer-reviewed stuff or studies or reports of studies type of things. There's a lot of stuff about COVID, but there's also other things happening as well that are there. History bits that are interesting.
All things science. All things science. Go to Landon's Discord. Hell yeah.
And if you get bored with science, there's news feeds where you can look up wacky stuff about, latest thing that a clown might have done, or Gladys Berejiklian's fall from grace, or other sorts of things like that. I try to, so if you don't like the political bent of science, of the news feed, you can focus on the science stuff.
Very cool. I might have to do a couple of Goblin reads featuring it, so that way I can update people with your links.
Yes, that'll last for 7 days, and I'll then, if I see you join, I will then go and put you into the science fan thing, and then you can see more stuff and even post some stuff there. We do. I also do work on there's a media area where I also have a news feed there as well. Same thing. But if you want all the cool science medical thingies, go to Our Favorite Universe.
There.
And eventually, we'll have. I will. When we work out the production schedule, I don't know how you do it with all the shows you do.
I'm everywhere all the time.
Being to do that sort of thing, and then you and I have to have a D&D discussion.
Yes, actually, I need to update people on that.
I found my dice collection. I found the rest of my dice collection with all
I will do a whole video dedicated to Landon's dice collection. Please. Yes, I'm here for it. I am working on, and I've got a handful of things done for the other channel that will be D&D dedicated, so look out for that if you guys are interested in D&D and Dungeons & Dragons. So it looks like Landon's going to pop by. I know we've got Steve popping by. I'm sure Dapper will pop by when he is available for a podcast that we're working on.
What's that channel going to be called?
The channel's called It's called Goblin's Lair, but it's layer like as in like an onion layer.
Okay. And by the way, also I also plug Dapper Diner. I'm
Dapper. What are you up to?
Does good stuff.
Yes,
check out his channel.
So actually, just today I had a interview with Dr. Josh Bowen of Digital Hammurabi. We talked about Mesopotamian languages. Which was a nice change of pace because almost every interview with him is about the Old Testament. But I wanted to do an interview that didn't touch on the Old Testament at all, and we managed it. So it was all about Akkadians and Sumerian and how they changed over time and how the writing system developed. Very fascinating stuff if you're into like ancient history or languages generally or ancient languages in particular. Check that out. It was just finished before I came on here.
Ancient languages are cool things, and I've always had these questions about information-wise and how compact they are and how efficient they are and so forth. But I'll have to check out that thing because ancient languages can be quite cool.
Let's see. Monday, I have first. There's a debate at 11 a.m. Pacific, 2 p.m. Eastern. It is going to be Dr. Dan Stern Cardinal of the channel Creation Myths versus Ahmed of the channel Finding Truth. Ahmed is a Muslim apologist, and Dr. Dan is, of course, an evolutionary biologist specializing in viruses, and they will be debating whether or not evolution can result in novel features in organisms.
Dr. Dan is lovely, so go support Dr. Dan.
We will then be having an after show, and then after that, there's going to be D&D, I presume.
Hell yeah, Monday night D&D. We play.
Come to this channel. It'll be
we're getting killed in the puzzle house. We're dead.
It's 4 p.m. Pacific, which is 7 Eastern. Am I right about that one, Chesh?
Yes.
Okay. So yeah, be here for that. Pacific. Then Tuesday will be, of course, more Kent with Bent. Thursday is going to be my next video about Genesis Apologetics. And then I'm going to be on vacation for a week. but
Ooh.
2 videos will come out that week. I'm going to be taking a little trip off to some big hole in the ground somewhere in Arizona. Apparently, there's a really big hole, I guess. So I'm going to take a look at that. Yeah.
Go check that
Apparently
out.
there's like a river at the bottom of it, I guess. I don't know. Yeah, I'm going to be there for a week or so. But there's going to be a pre-recorded Kent with Bent that comes out that Tuesday, and I've already got like 4 edited videos that are in the bag. Which, by the way,
Nice.
if you become a channel member or a patron of mine, you can just watch them right now if you want to. So
Nice.
that's
I
all.
have tomorrow.
Become a patron because he does cool stuff and should be supported.
Yes, for sure. I have 2 videos, 2 lives tomorrow. I will be talking about objectivism and a little bit about economics with Kirk Wilcox. If you don't know who he is, come find out. I'm really looking forward to that conversation because it'll be the first time I've chatted with him a little bit, publicly on Twitter, but this will be the first time I've actually gotten into a room to talk to him. His hair is fabulous, and I'm really looking forward to finding out what we agree on, what we don't agree on, and just kind of chatting away. Hopefully things go well. I don't think things will explode. He seems like a pretty great guy, so go check that out. The links to his stuff are also in the description already if you go check that out. Also, there will be a Keeping Up with Katie Joy on Sunday evening, because of course there will be. We're going to note how horrible she's currently being, and then we're going to actually go and look at the very first Smoking Nun on the Non Sequitur show with her and Kyle, and try to see how long it takes before our ears start bleeding. It'll be great. Apparently I hate myself.
Is this an attempt to try and detect intelligent life on
yes,
the
I
internet?
am trying to be wholesome this whole week, so I had to figure out how can I possibly talk about Katie Joy and remain wholesome. So I thought maybe if we look at one of her older things, it won't be as horrible as the current goings on. I'm doing my best.
Good luck.
If you did not check out Thursday's video, check out Thursday's video on Brendan Fraser. It is sad but wholesome and also amazing all at the same time. I laughed, I cried. It was a roller coaster. Please go check that out. It is a story and an amount of life that I think just needs a lot more exposure than it actually gets. So please, please go check that one out. And if you enjoyed it and if you hated it, share it with your friends anyway, because more people need to know about that. Do it. It's great. Also check out yesterday's video because it was really funny and very Halloween-y since we're starting into Halloween. I think the pup cam was a success. We have a pup cam now. I like it.
Today is the second day of Halloween.
Yes, today is the second day of Halloween. This was a wonderful conversation. I hope we get to do another one of these soon. I'm working on getting these sort of community commentary type show where people kind of just get in the Discord and we have a conversation. We got to feature Landon and Dapper today with a little bit from Nikki and some lovely graphics from Paul for a little bit, which is wonderful. And I just hope that as we grow and as we build on it, it'll get better. I now have community options for Discord, so we'll see how that goes. More developments as I figure it all out. But yeah, that's about it for me.
Check out your wonderful channels there and so forth. And by the way, thank you, Paul, for joining. I put you into the science fans section, so I hope you enjoy that as well. And I will keep track of stuff. Occasionally look at that to sprinkle in. But yes, once you become a science fan, you get to expose to good stuff. And check out Dapper stuff as well.
Threatening people with being exposed.
Well, I just said that, Paul. I won't say the details of who it is. And so, by the way, Dapper, you're talking about your A&D show. It's going to be 4 p.m. Pacific, and people come to your Discord.
It's 7 p.m. It's 7 p.m. Eastern time and 4 p.m. Pacific time.
Right.
Yeah, 16 Pacific.
Yeah, that's here. That's on my channel.
Yeah, so that's going to be always on Cheshire Vic's channel. It's Guns, Magic, and Steel. And it's every other Monday, assuming we can. We don't always succeed.
Yeah, we try. We try our best. We play D&G for charity.
Absolutely. It's 826. I can't remember the numbers.
826 LA is the one we usually focus on.
It's an educational charity, so they do work all over the United States. So if you want to show up to that and you feel like supporting, you definitely support by using the donation link that we have available to go straight to the charity.
Yeah.
Because Cheshire Vic doesn't share any of the super chat stuff with any of the rest of us.
Correct. Fuck you guys.
Oh, so I will, and now let's go because instead of doing 95% of the thing, you do 100% of the thing. That.
Yep.
Hey, I did some of that art, Chesh. Remember that.
Okay, so yes, Dapper did a lot of the graphics. I'm the one who put them together and make them look nice on stream.
Yes, Chesh is
So
definitely.
Actually, Erica did some of the art too, because she
That's true, Erica
did her and Luke's character portraits.
Mm-hmm. She's in the credits as additional art by.
Yeah.
Yeah. So I will check out the art Discord thing.
Yeah, enjoy.
For that, and also I imagine it'll be simulcast on YouTube for stuff. And again, you and I have to do a briefing on modern AD&D stuff so that I can.
5th edition.
Has it been since 2nd edition since you played?
I had some experience with 3rd.
Okay.
And 3.5 for there, and
So
I was looking at weight, and I got exposed to somebody showing me how bad 4th edition was. So.
Yeah, that sounds about right. But you're already aware that Thaco is gone, huh?
All right. We can
yeah,
keep having this conversation, but we're gonna get out of stream. Say goodbye.
Bye.
Bye, Puck.